The time, 0300 hours, 2025. The Kapustin Yar test range comes online for a scheduled diagnostic of a strategic missile system. Deep inside the complex, a Russian engineer initiates the cryogenic pre-chill sequence. But, according to Ukrainian accounts, their reconnaissance teams had maintained a 48-hour vigil on this military asset. They were poised to exploit a brief window of vulnerability, the moment the silo doors would open, exposing the missile support systems. A critical juncture in modern warfare, the shriek of opening doors was the signal. A $100 million launch installation, now targeted for neutralization in 47 seconds by 4 small $2,000 FPV drones from an OSA quadcopter team. This operation hinged on intelligence. Ukrainian military intelligence, the GUR, had reportedly intercepted scheduling data indicating a diagnostic test, not a launch. This critical detail meant the doors would be open, exposing vulnerable conduits and equipment. Based on this war analysis, Ukraine's SBU security service gave the green light. An SSRU Special Operations Unit, with the hardened resolve of battle-tested Marines, launched a plan to isolate and attack the exposed subsystems. 3 miles from the silo, 2 SSRU vehicles staged a traffic accident, blocking the access road and delaying any ground response from the Russian army troops. From a hidden compartment, 4 7-inch OSA FPV drones lifted into the foggy air, each carrying a shape-charged warhead, small modern weapons with just enough C4 to puncture critical points. The dense fog was a key tactical element. It reduced visibility and scattered radar, complicating. 3 a.m. The silo doors groan open. The engagement has begun. OSA-1 penetrates the perimeter, signature fully exposed. This expendable drone is the first move, a gambit to provoke an electronic warfare response. As OSA-1 crosses the inner line, a Russian EW sweep identified as a Krasuka-4 locks on. The control link is jammed. The drone goes dark. The FPV feed cuts to static, a calculated loss. The objective of this military operation is met. The enemy's powerful defense system is now focused, its main jamming lobe exposed, revealing its effective ban for the subsequent wave. With the jammer committed, OSA-2 and the remaining pair begin their maneuver. OSA-2 ascends, maximizing its radar cross-section. It becomes a second decoy, bait for a long-range shooter. A nearby S-400 battery answers the call, launching a 48 N6 surface-to-air missile. The intercept is immediate. OSA-2 is obliterated. The trade, a $2 million interceptor for a $500 drone. But the real currency is time. The long-range shield and the primary EW node of this defense system are now occupied. A window opens, just seconds for the final 2 drones to penetrate. OSA-3 and OSA-4 enter the kill zone, the short-range defense perimeter guarded by Tor M2 and Pantsir S1 systems. A Tor radar acquires OSA-3 5 miles out. A 9 M331 missile is away. The Ukrainian pilot dives. From 50 feet, the FPV drone plunges into thick ground fog, scattering the radar lock and severing the missile's guidance. The missile detonates harmlessly. An extreme low-altitude maneuver, using ground clutter to defeat a sophisticated fire control system. But the reprieve is short-lived. The final layer of defense awaits. A Pantsir S1 shifts tactics, from precision fire to area denial. It unleashes a ripple of 57 E6 missiles, creating a wall of lethal shrapnel. Its twin 30mm cannons prepare to engage. OSA-3 is shredded in the fragment cloud. The Pantsir's modern weapons then slew onto OSA-4. The drone takes shrapnel damage from a near miss. The FPV feed tilts. The audio whines with strain. Motor output plummets. A partial propulsion failure pulls it hard to the right. The final drone is wounded, destabilized, exposed directly over the target. This is the critical moment in this new era of modern warfare. The Ukrainian pilot, callsign Kovil, makes a decision. He doesn't fight the damage, he uses it, a testament to the skill of these troops. He converts the uncontrolled roll into a flight profile the tracking computer can't predict. A tight, spiraling corkscrew dive. He uses the silo's own superstructure to break the line of sight. The maneuver shrinks the Pantsir's firing window to a fraction of a second. By the time OSA-4 reappears on the Russian operator's optic, it's too late. It's perfectly aligned on a vulnerable component. At 3 a.m., the shaped charge perforates a 5-inch cryogenic line. The line floods the area with liquid nitrogen, a critical refrigerant for the twin Lawrence Kirk F systems. An uncontrolled spill cascades across adjacent subsystems. The extreme cold creates thermal shock. Metal contracts, welds, crack, and critical circuit boards fracture. Ukrainian sources claim a short circuit then cascaded through the warhead handling architecture, triggering a catastrophic sympathetic event. A key military update from the front. Conventional warheads detonated. No nuclear yield. The blast buckled the 48-ton launcher. A seismic tremor registered 1.9. As the haze cleared, the view was stark. The site's main launcher, an 80-foot, heat-twisted mass of steel. Wreckage from its vital defense systems was scattered across the perimeter. The war analysis from Kyiv was direct. The loss of one launcher was the first critical blow. This represented a significant hit to a limited weapons platform, with manufacturing measured in single digits per year. Second, its neutralization tore a massive hole in the air defense coverage, creating a new corridor for the Air Force to exploit in future targeting. Ukrainian reports detailed the attack's cascading effects. Communications from the military complex went silent for hours. Testing at other facilities was frozen. A full investigation was underway. The attack likely forced a diversion of high-end air defense assets from the front lines to protect the homeland. The official narrative claimed a training mishap. Domestic social media, however, showed the truth of the blast in this modern warfare. Kyiv's measured statements met a wall of official silence, reinforcing a core message. Coordinated, inexpensive drones can breach even the most advanced defense. The cost calculus reveals the brutal asymmetry of this global conflict. It unfolded in just 47 seconds. 4 drones, valued at approximately $2,000 total. They were exchanged for a $100 million launcher and the disruption of a multi-billion-dollar air defense network. This is the new military update. The attackers forced the defender to waste high-value interceptors, revealing their electronic order of battle. But this was not an isolated incident. A second operation was in motion. The target, a $10 million Krasuka-4 electronic warfare vehicle. Not a fixed site, but a mobile asset protecting a convoy on the move. It was shielding an offensive approach. The compromise didn't come from a satellite or a spy. It came from one of the soldiers' own social media videos. Ukrainian army cyber analysts reportedly extracted the GPS metadata. The error margin was minimal. A targeting solution was built in complete electronic silence. At 3 a.m., a 2-layer deception began. High above, 5 jet-powered Banshee decoys climbed into the darkness. They broadcast the signature of a fighter squadron, forcing the sector's radars to look up. Near the ground, the real threat closed in. 10 FPV drones dropped to 30 feet, hugging the terrain. They flew on preloaded waypoints, their memory holding a visual template of the EW antenna. This was for terminal recognition if GPS was lost. At 3 a.m., a Tor M2 in the convoy engaged the decoys, downing 3. The launch illuminated its own position. The emissions were recorded. On the ground, troops scattered. Marines deployed handheld jammers, severing control links to 2 of the low-flying FPVs. At 3 a.m., Ukrainian electronic support, having captured the enemy frequencies, tasked a designated FPV for a special mission, a digital sniper. It saturated the Krasuka-4's receiver, blinding the node in a storm of white noise. 7 FPVs shifted to silent run. They navigated on inertial systems and stored maps. 3 others were retasked to suppress the infantry who had revealed their positions. At 3 a.m., a Beryeva 50 command post arrived on station, feeding the Tor look-down targeting data. The Tor launched again. The lead FPV executed a decoy dance. It deployed a fiber-tethered radar enhancer, pulling the missile away from the swarm. The warhead detonated harmlessly. At 3 a.m., the assault continued. A wolf pack of FPVs hunted the dismounted troops in the tree lines, striking 2 teams. The others broke contact. At 3 a.m., 6 drones converged on the Ural EW truck. They used the antenna's visual fingerprint for a terminal lock. The lead drone detonated its fragmentation charge inside the enclosure. Overpressure, shrapnel, secondary fires. The system was dead. Across the convoy, perimeter radios fell silent. Escort coordination collapsed. By 3 a.m., the EW shield was down. The T-90 tanks and BMP-3 fighting vehicles were exposed to accurate fire. Fuel and ammunition trucks stalled on the road. And in that window of chaos, Ukrainian forces began their counterattack. The war for this sector had just begun. The 2 actions, one at a silo complex and another on a mobile EW convoy, share the same operational logic. Both were part of a coordinated military effort. They used low-cost platforms to force expensive defensive reactions, gather targeting data, and then strike high-value targets. This warfare relies on a layered plan of electronic support, decoys, and precise terminal guidance, not massed firepower. The goal is to gain seconds, forcing defenders to react off-script, a hallmark of this global conflict. This war analysis reveals key tactical lessons. In the first engagement, OSA 1 and OSA 2 were sacrificed. Consumable assets used to draw the fire of EW and long-range air defense. This cleared the path, reducing complexity for OSA 3 and OSA 4's final run. In the second engagement, the tactics were adapted. Airborne decoys and a fiber-tethered radar enhancer drew missile fire, protecting the core swarm of drones. In both cases, human pilots were the deciding factor. These soldiers were operators, exploiting every advantage: environmental fog, line-of-sight barriers, and even the target's own structural features. The objective: to degrade enemy sensors and maximize the impact of small charges. A key strategic lesson is emerging. The cost-effectiveness of defense is now a battlefield. When expensive systems repeatedly face inexpensive threats, every use of long-range interceptors or high-end radar provides the attacker with exploitable data. Over time, that data allows an enemy to tailor their weapons and tactics, jamming, terminal profiles, decoys to the specific defense technology they face. And that was only the beginning. The war analysis is stark. $2,000 in quadcopter drones against a $100 million launcher. A handful of FPV drones against a $10 million electronic warfare asset. The math is brutal. The defender was forced to expend its advanced weapons. Their entire defense architecture was exposed at a staggering cost, while the attacker risked only cheap airframes. As dawn broke, the scenes were identical. No large formations clashing on the horizon. Just the silent, static image of disabled modern weapons and severed command networks. The smoke and fire are tactical. The true consequence is operational tempo. The question is who can reconstitute their troops, which army must redeploy, and which corridors of this global conflict now lie open because a fixed shield has a new hole. This military news comes with contested claims of internal detonations. The extent of the damage, the command choices made. This is the operational narrative, pulled from Ukrainian military sources and raw battlefield feeds. Yet the method is a clear chapter in modern warfare. Isolate, distract, measure, then strike the critical node of the defense systems as new defenses adapt. Tighter emission controls, faster handoffs between layers. The same question now drives the next move for every branch: the Air Force, the Navy, the Marines. Will low-cost swarms of drones and tailored decoys continue to buy the seconds soldiers need inside layered air defenses, or will improved defense technology and sensor fusion and advanced counter-UAS tactics erase that window for good?